All right, we're looking over exponential functions now. We've got the equation y times b to the power of x. We've got to remember that our a is our y-intercept, as well as our starting point. And the initial value. All right, so whatever's in front of the parenthesis is going to be the y-intercept. Remember, our y-intercept is 0, comma, a number. It's going to be where we start, and it's going to be our initial amount of money, bacteria, multiple ways you're going to see it. Your b, though, sorry, let me change the size. Your b, that's going to be your growth or your decay. When it becomes the growth or the decay, you've got to remember that a growth, and you've written this multiple times now, your growth is 1.00 plus whatever. And then your decay is always going to be 1.00 minus something. Minus something. So, for example, I'm just going to write that over here. For example, I've got something that grows at 13%. I need to know that this 13% as a decimal is 0.13. Since this is a growth, I'm going to add it to 1.00. So this will be 1.00 plus decimal 13. My b would end up being 1.13. This is where some of y'all mess up. You can't just go and put this right here. You've got to put this value. This is not it. All right. Exponential growth. B is greater than 1. It has to be bigger than 1 if it's a growth. It could be 1.01. It could be 5. It could be 3. It just has to be greater than 1. If it's a decay, your B is between 0 and 1. This is where we get the decimals from. For example, we've got 0.73 or 0.31 or 0.95. These are decays. They're in between 0 and 1. So think of money. All right. So we're looking at this problem right here. It says y equals 3 times 1.12 raised to the power of x. It says, what is our initial value? Our initial value is where we start. The initial value is where we start. That would be 3. All right, now it says, is it increasing or decreasing? We need to circle which one it is. So I am 1.12. 1.12, remember, growth greater than 1, exponential decay in between 0 and 1. 1.12 is definitely increasing because it's greater than 1. Now it's asking me at a rate of blank percent. So let's look. I'm at 1.12 and I started at 1.00. So what happened? How did I go from 1.00 and end up at 1.12? Guys, it's simple. Look at this right here. 0.12 is what I added. If I take this 0.12 and change it to a percent, it's 12%. So my rate is 12%. All right, I'm looking at my next one. It says y equals 50 times 0.92 raised to the power of x. It says, what is my initial value? Initial value, remember, is whatever is in front of my b value. That's going to be 50. Is this increasing or decreasing? Well, decay is in between 0 and 1. This is like less than $1 if I think about money. So this would be 92 cents. This would be decreasing. This problem would be decreasing. All right, so now it says at what percent? So guys, if I was at 1.00, 1.00, and now I'm at 0.92. Just think about it. How many pennies did I have to take away to get to 92 cents? Well, you could literally do that in the calculator. 1.00 minus 0.92. This would give us 0.08. I took away 8. So that would be a percent of 8. Last part, your asymptote. Your asymptote. This means what number do we get close to, but never touch? What number do we get close to but never touch? When I'm right here, this would be my asymptote. It would be x equals what? What number are we getting close to, but we are never going to touch? Well, if I look closely, I went through number 3. So x equals number 3. Let me rewrite that, make it a little prettier. X equals 3. So that's your exponential functions.